Right, guys, we're going to move on to our next talk, enhancing AI with real-time data, unlocking contextual insights. Tom, CEO and co-founder of Streambased, is a seasoned distributed systems and data integration engineer with over a decade of experience. He has led transformative changes in data engineering with expertise in big data at Cloudera, event streaming at Confluent and Conductor, and now streaming data lakes at Streambased. Tom consistently pushes boundaries to maximize the value of data-driven solutions. If you can all put your hands together for Tom.
We got a mic? We good? Yeah, magic. All right. Thanks, guys, and thank you for coming along to my talk. This is enhancing AI with real-time data. Apologies in advance if you like to track with me. I like to wander around and I'll wave at you and do all of that kind of stuff. Try and focus on the screens. They're much more exciting and pretty than my face anyway. Unfortunately, I have to start with a confession. As was mentioned in that lovely intro, I'm not a data scientist. I'm the enemy. I'm part of the data engineering, more of the data engineering tribe. But the good news is I've spent a long time working with data scientists. You're a miserable bunch, you really are. Terrible. Much less miserable than data engineers, I should clarify on that one. Right. And the most common thing that I hear from, well, I ask the same question to every data scientist that I see. So, and we'll try again today. Let's see. Today might be my lucky day. I say, stick your hand up if you have every single piece of data you need to solve all the problems you have today and tomorrow in the future. There was one. That was nearly my lifelong mission, didn't you? No, sorry. We'll have to wait another time for my lifelong mission to be achieved. Yeah, it's true. So I've spent a career, basically, in providing new data sources to interested people, BI, AI, ML engineers, data scientists, that do all the interesting stuff, really. You guys are lucky. You get to go, look, I did this really, really cool thing, and take all the credit for it, when it's really us hardworking data engineers that provide you with all the data to do it. So with that in mind, this talk probably isn't going to show you some magical new analytical technique that's going to change your life. If any of you guys were in the GraphRag talk a minute ago, did anyone go to that? That was a magical technique that will change your life. That was amazing. All right. This is going to be more about new data sources, new ways to think about how to gain insights, and we're going to do a few things. We're going to talk about real-time data. I'm going to purposefully leave that vague for this slide. So we're going to outline some core concepts. We're going to then take an AI look at it, particularly a Gen AI look at how we'd use real-time data, and we're going to run through an extremely contrived example. So you've all had a little break. You've all gone back to sleep, and everybody's feeling a bit droopy. So they say, what you should do is start with a slide that really grabs people's attention, either really exciting or really shocking. If that doesn't scare the crap out of you, I don't know what will. Right? So the gap between collected and accessible data is widening, and it's widening by a huge way. You guys are working with new and interesting types of data every single day. Do you really want to get to 2028 and only have like 10% of the data generated in your organization available to you? It's kind of a scary thought. There's a lot of opinions on why this gap is happening. I'm going to share mine because it's my talk, and I can. Feel free to argue with me at the end, so I've got no problem with that. But the simplest way to explain it is that there's a lot more applications, people are doing a lot more stuff, and that's generating a lot more data. I think that's too simple. I think that's much too simple. That's always been the case. There's always been a jump in the way in what people are doing with software and IT, and data has always managed to keep track. What I think is changing right now is the way in which we interact with applications. Software has moved from being a reflection of the functionality of a business to being a rich and immersive experience in itself. And I quote Uber because you're going to hear Uber so much in this talk. If you're talking about real-time data, you're either talking about Uber or LinkedIn, so sorry. It's going to be lots and lots of Uber. If you take things like Uber, the core sort of functionality of that app platform is to book a ride, get in the ride, and pay for the ride, right? But instead, you get the little cars that drive around the street. You get up to the millisecond updates about where your ride is and the status and things like that. It's that kind of immersive experience that is driving the success of it. Think about Amazon's another great one, right? A few years ago, we'd place an order, you'd get an estimated delivery date, and maybe it would turn up. Now, I don't know if anybody, I'm giving away my secrets here, but I don't know if anyone else does this. Now you can track the truck from 8 stops away and make sure you're at the door before he is. No? Anyone try and freak Amazon drivers out like that? No, it's just me. Okay, fine. And it's not just nice experiences that do this. We have up-to-date financial information, which means we can make things like loan decisions in under a minute. Fraud detection is a huge one. We can now intercept fraud before it can even happen because we have real-time data that's possible to do that. So let's just have a quick clarification on what real-time is. We've talked about our little Uber cars generating data points every single step of the way so that they can show their movement in the application. That's data that's generated and made available as quickly as possible with little delay between collection and analysis. That's like the textbook definition, and you'll notice I've crossed out made available because the most common question I get when I talk to people that are new to real-time data, and you're going to love this one, is at what latency does it become real-time? That's the number one question I get. Any high-frequency traders in here? If you ask a high-frequency trader, they'd be on the nanosecond. Milliseconds too long for those guys. At that point, it's not real-time. That's collected batch stuff, right? I typically work with Apache Kafka that we'll talk about later, and we're sort of in the milliseconds, hundreds of milliseconds. You go across to the Met Office or someone like that, they're talking about weather collection, and for them, real time is every hour. That's right. So I don't think the latency really, really matters on this one. What is important is your intention with that data. For me, and it's not for me, it's for everybody. For me, real-time data is data where you intend to act upon a data point that is generated immediately. Yeah. So, and the intention is there, and once the intention is there, it doesn't actually matter if it was a second later or 10 hours later, right? The intention and the way we designed our application was to act on it immediately. In short, we're talking events. From now on, I'll use event streaming and real-time data interchangeably because they really, really are. If you take a look at the physical world and the real world, what real-time boils down to as a way in which we interact with the world is an event. Something occurs and we react to it. And it's this paradigm that we bring through into the software world. Oh, look, there's an Uber slide. That's a surprise. This is a little bit out of date, but this is really the way Uber, long way back, probably 2015 odd, carved up their business and began their real-time journey. They split it up into a set of domains, passenger management, billing, driver management, and these would consist of a set of services that were experts in their area. If you think of driver management, they would have a service that would allow a driver to register himself as driving at that point. Right? It's a very specific expert. Right? And then that service would consume and produce events around that service. So I would produce an event to say, I've signed on. Okay? And just like in the real world, I want you to imagine it as getting up on the roof of this building with a 10-foot megaphone and saying, I'm signed on, I'm here, I'm ready. Right? That is what the driver management service that is doing in this point. Other services around here are listening for these events and want to react to them. So I picked a bad example, didn't I? I've signed on, would then show on the driver web, would then be broadcast out to the driver web UI, and on his phone in his car, he sees a little green button that says, I'm now active. Right? This is the world we live in. So what we end up with is a set of experts, a set of services that are working together and coordinating with each other in order to achieve their goals. Who knows what the logo is in the middle? I know a couple of you do because I've already mentioned it. Shout, don't. Kafka! We can do better than that. Kafka. Well, there'll be more Kafka logos and we'll get a louder shout at Kafka in the middle. Kafka is the software way of making this happen. I'm not even going to pretend like it's not Kafka. If you're doing real-time data, you're most likely using Kafka or Rabbit, and we don't talk about Rabbit. So, it's a consistent bus, if you like. It's a consistent hub for all the data where we can define flows and where these services can find data and use it and react to it in the way that they like to. This one is an Uber. There's a reason for that. The Uber one was like white on a black background, and it worked really, really badly on the slide. Otherwise, it would have been Amazon. It would have been Uber. This is Amazon's retail business. Again, a little bit out of date today. It's probably an even bigger ball of glue. But this is a 3D visualization, and you won't believe it, but each one of these is one of these little expert services that I was talking about. That is how Amazon's retail business coordinates with itself in order to achieve the goals of the business. So it's huge. And you can imagine that every single one of those services is both consuming and emitting data points and events. What I want you to do is just take a moment and imagine the amount of insight that is stuck in that big black ball. Right? And as of today, unexposed. So, a couple of key points on that. Real time is not just the point at which we communicate with each other and we coordinate, it also tends to be the point of ingestion. As I mentioned earlier, real time models real life really well because events happen in real life. So, if you think of, it's just so easy to explain. When you design applications, what do you think about? You think, what is my user doing? Right? Every action that your user is performing is an event in itself, right? So it just models the real world so well. So if you have a user that is clicking on a button, placing an order, these are actions, these are events that can be modeled in your real-time system, and in modern forward-looking data-driven organizations, that is what's happening. So where maybe 10 years, I'm going to say 10 years now, where 10 years ago, that will be modeled as a row in a database, that doesn't necessarily make sense. A row in a database is a very static thing that has to be processed by a further action that is either triggered, triggers work kind of well, or by some kind of polling operation. That's not what we want to do. We want to react immediately, and we want to coordinate, and we want to work together to solve our problems. So real-time data is most likely the ingestion point for all data into your business today. That means it's the rawest of the raw. You want to see where the shit really hits the fan? That's it. It's there. And unfortunately, and it is very unfortunate, are there any data engineers here? Because I want to know how much I can insult them. Oh, just the one. All right, sorry, buddy. You're going to get the brunt of this then. Unfortunately, usually the first thing that's done with that ingested data is it's rolled up or aggregated or some way, and precision's lost, and you lose some of the data. That's because it's a great fit for operations. We talked about coordinating our services. That works really, really well in creating a maintainable and evolvable operational infrastructure. The reason Uber decided to build in real time right from the beginning is because they knew that the service and the product that they were going to build was going to change massively, and they needed to be able to accept that change. If you have a group of experts working together in order to solve a problem, you can easily swap one out or add another one or something like that. Let's take a real-world example. If I've got a very, very difficult problem, I can assemble my entire team in a room. Right? We can thrash through it. A production issue. Everyone's been on those conference bridges. That's what you do. You put everybody in the room, you thrash it out until you come to a solution. What you don't want to do is go, there is one guy somewhere. He's learned everything, and he's the only person in the world that can solve this, and if he doesn't want to solve it, then we're screwed. Right? There's one more point that comes along with this. This one, I put it at the bottom, and it really should be at the top. It's kind of the most important part. We're talking about reacting gracefully to change. We're talking about accepting new data, and we're talking about things like that. This is difficult. Right? It comes with governance problems. It comes with trust issues. It comes with security stuff. what I'm trying to let you guys know is you can cheat. It's a big cheat, right? Because this is operational data, all of this stuff has to happen anyway, right? It's happened. The data points of Uber cars flying around, I will come up with something other than Uber, I promise. So I've got Uber on the brain. Those have a strict schema. That's been defined. That's evolved. It has to, because they are interfaces with other services, right? And as that evolves, we gracefully accept the change. So in our analytical world, why don't we do more piggybacking? Let the operational guys do the work. Why should we have to then do it again in order to bring the data across this invisible wall between operations and analytics? An aside, this is just me being a bitter old man again. Normally at this point, we're doing questions at the end, but normally someone's put their hand up and go, but I export everything to the lake, and then they sit cross-eyed with a very smug look on their face. That's great. One, you're lying. You're not exporting everything to the lake. But even if you were, it's not really something to be smug about. What you've done is created a really expensive and complex version of something that should be very, very simple. You've got 2 copies of your data, one in the operational realm, one in the analytical realm. You've got a really complex ETL process that goes in the middle of it. And purely by having 2 copies of the data, you've now got an inconsistency thing. Who wins in a fight? The analytical world or the operational world? So it's about time. That's my data pitch and my thesis for life, I guess. It's about time we started to think about the new sexy stuff, the new AI stuff, and in particular, generative AI. LLMs are amazing. They really are. They're way beyond my thinking. You guys who work with them, hats off to you. It's brilliant. But they've got some major drawbacks. Most models today that we have are frozen in time. Anyone who asked what the weather was like in San Diego from GPT-4 got, as of November 2023, which isn't all that useful, to be honest. And because there's a lot of effort that goes into training that model. There's a huge amount of data that goes into training that model, and it's a very, very batch process. I actually think I can't wait for the day when that is going to become a much more real-time process in itself. It's coming. It's going to be very, very cool. But for now, we have what we've got, which means we've got something that's a really good talker, really nice to know, happy to chat with, but a bit dense. You know, not really up to date on current affairs. They're also very, very naive at context for the same reasons, and it's very, very expensive to add that knowledge. What are you going to do? Retrain it with everything up to date when you need it? Well, yes, actually, but not today. We'll do that in the future. If you compare those with event streaming systems, right, they're not very chatty, I have to tell you. An event streaming system isn't going to be great for having a conversation. But it is going to be great for having the very, very freshest and latest data instantly available to you. It's also extremely contextually aware. We saw that big ball of services. That is the entire of your business in that ball, right? Everything you could ever need to know about what's happening right now, it's in there. And they're also super, super cheap because they have to be their data systems rather than giving value in terms of processing, they give value in terms of storage. So optimized massively for being inexpensive. So it sounds like we've got a really nice set of opposites here. And if we could combine the two, we could create something really, really powerful. And yes, we can. A reusable and intelligent tool. And yeah, before anybody asks, we're talking RAG. I'm not a RAG expert at all. I'm not even an AI expert. But the general principle is exactly what we want to do with our LLMs. Please tell me where all of my AI stuff is going wrong. The examples I'm going to show you are hideously bad, but that's for a reason. I'm not pushing the AI side of things. I'm pushing the data integration side of things here. So let's have a quick recap. What we really want to do is take the thing that we feed into the LLM and enrich it with some kind of context that means it can do a better answer. I always like to think of it, I mentioned it earlier, I always like to think of it as this guy over here, he's really good at talking. I try and keep my LLM thought processes down to they're really good at natural language. good at natural language understanding, good at natural language responses. Further than that, not really that useful. Sorry to burst the bubble on that one. You have to feed it everything it's going to reply to you, but it's really good at understanding what you're feeding it and replying to it. So for RAG, we need to enrich it with context. That means understanding the query, converting it into something that represents the context that we want to add, and then pushing a whole load of context in. And this is done with a vector database. Everybody's seen this already at least 4 times today, so let's carry on. But the point I want to make here is event streaming is your context. It's a consistent hub of everything that's flowing through your data. Okay? And that doesn't matter whether we take the view of it of platform sources or whether we take the view of it as logical sources. Right? It doesn't matter. It's a very, very mature set of technology. I guarantee that if you go back to your data engineering team and say, do we do any event streaming? They're going to go, yeah, we do quite a bit. Right? It's so prevalent now. Kafka's in 80% of Fortune 100. It's in all the largest insurers, all the largest. You will have an event streaming infrastructure that you can go and play with. And yeah, there's a Weaviate connector, just in case anybody cared. Right? So what it's great for using for is sourcing unusual and original and new sources of data, converting them, we'll talk about that in the next slide, converting them into a format that's really, really useful and pushing them out to somewhere else. So if you want up-to-date if you want your database up-to-date, VectorDB, up-to-date with the absolute latest and freshest data available to your business, it's a really good place to start. And I'll only touch on this because it's cool. We built stream processing into event streaming. Stream processing is an automated way to react to these kind of events. Anything new that happens, we can go, oh, we've noticed it's happened. Think of it a bit like a trigger in a database, but much, much faster and much, much cleaner. You can do stateless processing, or you can even do stateful processing of the data that's flowing through your event streaming database. Again, with my examples, let's say we want to build a knowledge base. That knowledge base is going to come from one or more of these logical services that are all pushing their data into this central hub. We can join, filter, clean, chunk, and build that knowledge base in real time in a process that you guys don't even have to worry about. Once you have your stream processing defined, your knowledge base is just taking care of itself, and it's doing it every minute of every day. I'm getting there. There's just one more point I want to make about stream processing, because I think it's an underlooked at point in generative AI right now. LangChain's great, but in terms of AI orchestration, there's a lot more that can be done here. And stream processing allows you to embed your AI applications in AI models, or even if you want to do remote call, procedure calls and things like that, you can embed it in a reactive process. Kind of like, I've done some experimentation with this, and I'll just let you know it's a really, really awesome way to spend a lot of money on OpenAI without realizing that you've done it. But, but yeah, if you need that up-to-the-minute reaction, if you want to gain the insight that's possible from leveraging your AI models, why not have them react directly to data incoming in the operational world? There was a great talk on ML ops this morning. This is going to be, event streaming should be a massive part of ML ops. So that kind of explains the theory. I always like to do it with an example. We're going to work through a very, very contrived and very, very wrong example here. So feel free to point out where I've got everything wrong here, but it's good. But as long as you get the principles, that's fine. Shift left net is a social network with a spam problem. So a social network designed purely for people talking about shifting data infrastructure to the operational side. So it's massively popular, as you can imagine. Facebook's got nothing on these guys. Interesting conversations happen between its users every day, but they're constantly being interrupted by merchandise sellers. No doubt everybody's experienced this. You take your favorite Facebook group or whatever, or start typing, and then t-shirt sellers, t-shirt sellers, t-shirt sellers, all the way down. It's all over the place. These guys are a modern data infrastructure, so they built from the ground up with real-time data. Their architecture looks like this right now, which is somewhat basic, but works for our things. They have a post service, helpful for people to be able to publish new posts on a thread. And they have a feed service that aggregates posts together and presents you with a feed. That feed then goes to a presentation service, and that's how you interact with it as a user. Makes sense, right? No worries. Then the spam started. So we use stream processing. Stream processing is great. And we did something very, very simple. We went for simple keyword searches, things like that, and we started blocking posts based on those things. Great. Worked fine for a while. Operates on each message in isolation, each post in isolation, without taking a holistic view of the world. And yeah, it sort of works. And then the spammers evolved. God help us. So instead of having buy my t-shirts, which was easily caught from the spam filter, we got some kind of ChatGPT generated. I'm really, really interested in subject X. I have the following list bullet points because it always generates a list. I have the following views on this subject. By the way, here's a t-shirt at the end of it. Right? Much, much harder to catch via a simple single data point spam filter. So we had to go back to the drawing board. We're churning users here. This is happening every day because they're really frustrated with the experience. So there's a bit of a constraint on here. We want to use an LLM to solve this. And particularly, we want to use RAG to solve this. So what we're going to do is we're going to have a prompt that looks something like, given this post, new post. Again, stream processing, wonderful. We can react to new posts coming in because we have a post service emitting the event that a new post has come in into our event streaming world. In the theme of, and we're going to use the post from the feed services, right? Why not? We have a feed service that shows the entire thread, so we'll post that in. Is the post having a positive or negative impact on the discussion? Answer yes or no. No one's thrown anything at me yet. It's the worst prompt ever, right? But it's there to demonstrate the principle. If you actually were to try using this, it would do absolutely nothing like what you wanted it to. But it demonstrates the principle. And did that work? So before we move on to whether we find out whether that worked or not, let's just have a little look at whether we could have used an alternative data source for it. Data lake, everything's in my lake guy is going, yeah, I could have got that from my lake. But it's a huge volume of data, and in most cases, the data sets like this, at the very, very raw end, aren't going to be transmitted to your lake. What's much more likely is you'll get some kind of roll-up of user post count, and that's the data that you poor people as data scientists are working with today. I do feel sorry for you. There's so much more out there. And why are you not working with that kind of data? Well, it's hard, right? It doesn't have to be. There's this thing about continuous streams of data where everybody assumes that standard tools and techniques just don't work with them. And you have to do something very, very fancy. In the advanced stages, I'm not going to lie to you, that is true. If you want a fully event-driven architecture where you're constantly responding and reacting to things, then yes, it gets tough. But it doesn't have to be at the beginning. There are a bunch of tools out there. Streambased is a great one. But there are a bunch of tools out there where you can literally just downcast real-time data to a batched table, or it looks like a table, or it looks like a data set that you were just using at that point in time. So you're still getting the freshest of data. You're just presenting it as a snapshot at the time, and then use it in your applications. I'll talk about us because we're awesome, but we integrate directly with your notebooks, directly with your anything that speaks SQL. We can integrate with your operations pipelines, anything like that. And it is just basic ANSI SQL that you write. So you won't, if we've done our job properly, no, you won't be able to tell that it's a real-time source. You'll just see it as another data source. We're not the only guys that do that. There's a few people out there. So, what have we done? Did it work? So we've fetched this point from the real time, and we're reacting to new messages coming in. We fetched this point from real time because we can downcast our real time feed to batch and select only the data that we want out of it. Have we got a solution here? Almost. The problem is there's too many posts. Shift left net is really, really popular. We're going to start hitting LLM limits. We're going to start hitting token limits and things like that. And and even if we don't hit those limits, we're throwing so much at the LLM that we're going to start losing precision and consistency on here. So how do we solve that? Well, we go exploring. We have this huge ball of real-time data. Let's see what else we got in there. Maybe there's something that can help us. And once we're going and doing our exploration, we find this like service. And the like service allows you to promote certain posts as things that you found interesting. And these are promoted as things that are very, very relevant to the discussion. Sounds great for scoring, right? It's almost as if somebody contrived this example to make their point, but yeah. The idea is that this kind of insight and this kind of extra insight that can make the difference in your applications exists in the real-time data. It exists in the operational world. And you're not going to see it because, well, I say it a bit later, you're not going to see it because it's not in anyone's data catalog. No one's thinking about this. So what we do is we take the post, we start ranking them by light, and the world's brilliant. Now we have a really, really good example where we can be pretty confident that if we put this shocking prompt into our LLM, we get a yes or a no, and it may have something to do with the question we asked it. And once you've done that, rinse and repeat. There's bound to be. The like service was a great find. There's probably a few more. I feel like these two worlds of operational and analytical operate independently of each other. There's so much exciting stuff happening over on the left side that's not reflected on the right side. And this spirit of exploration of these new data sources is missing. That's really what I want you to go home with today. I want you to go and explore real-time data, find new stuff, and well, enjoy it, right? That's why you got into this business. A couple of points on where we can inject real-time into our AI and ML applications. We've covered most of these, so I'm going to do this really quickly. Right? It is the point of data ingestion. It's also a really great place to explore for new insight. It's a great place to do post-processing for governance or continuous improvement. I should have put pre-stroke post-processing because it's also a great place to do chunking, filtering, and knowledge-based creation. It's also a really good way of doing orchestration for your applications and things like that. In other words, if you want to react to anything, or if you want to force something to happen, think about real-time as a source or a sink for making that happen. So the big $64 million question, why isn't everybody using real-time data in AI today? Well, I'm not naive. The answer is they are, right? They're forward-looking people that recognize the need for fresh contextual information. There's the guy who puts everything in his lake. That still works. And they're looking for real-time information. But as I mentioned before, there tends to be this wall between the operational world and the analytical world. And so very little gets across that. It's not discoverable because it's in no one's data catalog. Yeah, the next slide is a challenge to you, but data engineers, like me, tend to provide you what you ask for. But if you're not really engaged in that operational world, you don't know what to ask for, right? You're not even going to see it to be able to know that it could be useful for you. It's not easy to work with. We talked about that. And it's expensive to get started with. So that was a very, very long way of me challenging you to go and do the following. This is a call to arms for real time. It's not visible to you today, but it could be. Go hassle your data engineers. Go make their lives miserable. What I really want, my ideal scenario for finishing this talk today would be that every single one of you goes back to your business, goes back to your organization, and goes, why can't I have Kafka credentials? Go ask that question and watch that data engineer sweat. He won't like that. And I'll just run through that conversation with you, because the next question you're going to go is going to go, it's hard, it's not for you. Right? At which point, don't accept that. Go, no, it's not. It's really easy. There's Streambased. There's KSQL. Like, no problem. And then you go, well, do you really need it? And you go, yes. There's a huge amount of insight, and there's a huge amount of extra work that I can do that's sat in there. And then the last thing I want you to do is fight, get that off across the line, and then enjoy it. Go explore, go poke around, go find the things that nobody else is seeing because they're hidden in the operational world. And on that note, I'll invite some questions. Thanks, guys.
Yeah, raise your hands if you have questions, and I'll come around.
First of all, thank you very much. Really good talk. I kind of get it that you're very pragmatic from from the way you presented your work, but I'll still ask the question anyway. So, doing Gen AI on real-time data and trying to do inference, and so for instance, trying to do RAG on real-time data, where you're creating embeddings, to me, would be very expensive and extremely, maybe even difficult. But and I know you kind of alluded to that, but can you just kind of call out a little bit what sort of things would you have to consider? That's one question. And then the other thing is, you talked about being able to find, explore. So as the data comes in, you explore. On that theme, equally, you might also want to do anomaly detection. Could you just kind of share a little bit, on how you would solve those two things I just mentioned, please? Thank you.
Yeah, absolutely. So I'll grab that off you. So yes, it can be expensive, but the real expense comes in it's not in the processing that you do. It can be in the processing you do, but you're not going to hit that first. Right? The real expense that I think you'll see if you take a slightly higher look at the organization rather than the use case that you're looking for is in getting the data from the operational side across to the analytical side. I guarantee you that your ChatGPT costs will pale in comparison to your data lake costs, to your Redshift costs, to your once you start to hit a significant amount of scale. So the whole point of this shift left movement is to streamline that process, is to make that as painless as possible, to create as minimal copies of the data, and to push the point at which we query the data as far into the operational realm as we possibly can. So if you take away those analytical systems and the ETL processes that support them, you save yourself a ton of cash and you fund it. I've forgotten the second question.
Exploration.
Yep.
So that way you're picky on what you really want to push through your LLM. And in doing that, are you also doing some sort of anomaly detection, or because you're obviously doing stuff on this real-time data as it comes in, it's ticking, it's coming in. A lot of data?
Yeah, so the question was on exploration and anomaly detection and the kind of things that you can do. I think the two questions are related. Once you have shifted left and once you've pushed everything as far as you can into that operational, exploration becomes inexpensive and it becomes fairly easy. By exploration, I mean I want you to go and look for new insight rather than apply a particular use case. I can tell you a great example, actually, that came from a couple of weeks ago. There's a guy who noticed a memory leak in the applications because for some reason they were correlating, I think it was either a clickstream or some kind of application events, right, with system logs that they also happened to notice were logged into their event streaming system, right? And they noticed that once specific load levels were reached, they didn't come down again, right? So something's gone wrong and we go and investigate. Saved them a bunch of money in the end. I don't know what they were looking for originally. That wasn't it. I guarantee they definitely didn't go out to search for that. And that's kind of what I mean by this spirit of exploration and the fact that there is so much extra insight contained in the real-time data.
Thank you.
Quick one. Oh, sorry. Got your phone.
Thanks. You've mentioned the the technical process of doing stuff. But the reality, especially in larger organizations, is that the budget owners protect their fiefdom with, lack of a better word, with a knife. And data engineers or folks that are just a bit more curious about data have to navigate this minefield, right? And I think all of us have been through projects where things have not worked out as they should have. Do you want to just comment and educate the group on the politics and the human behavior elements of the technical stuff you talked about?
My God, how long have we got? I think I'm going to need another 3 talks for that one.
1 minute?
So in 1 minute, yes, there are political elements to this, and if I... No, not working fine. If I was to pull up the Uber thing, an organizational change is often required before any of this is really useful. You guys will all be very, very familiar with data mesh principles. Data mesh principles work really, really well with real-time data, and they work really, really well with the operational side of your business. This idea of curating data products and presenting them is wonderful. Where I talk to a bunch of engineers and engineering managers around a data mesh is the analytical side. By its very definition, it's very centralized. It's very, very difficult to create that capability within disparate teams and maintain product ownership. Shift left helps with that, right? This is we can see this as a bonus rather than a risk. What you do is you keep the operational side of the business that has to be separated, that has to be owned, that has very, very specific grounds around product ownership, and you introduce a much more free-form analytical access to it. The next thing that everybody says is, oh, we've got governance, we've got controls, we can't have everybody just moving around in our data and doing whatever they like. I counter that with the same exists in the operational world. You can't have every service going. You have the same problem with a hub, right? It's a centralized hub in your Kafka, right? You can't have everyone just jumping in at any time. So those controls, those governance applications and things like that do exist. You just need to get people used to applying what's applied in the operational world into the analytical world too. I said that like that was my 1 minute answer to it. I said that like it was a throwaway comment. It was really easy. That's really, really hard to do as a change in thinking for your organization. But the benefits are enormous. So if you can get it across, by all means, go for it and do it. Thanks.